This video series introduces you to some of the features in Optim Development Studio that you can use to develop an application that uses pureQuery annotated methods. This three-part video series is based on a tutorial that you can read and print from the Integrated Data Management Information Center. It uses the GSDB sample database, which is a sales database for a fictional company called Great Outdoors. In this first module, you will learn how to create a Java project in Optim Development Studio and add support for pureQuery to it. You will also learn how to generate code in SQL directly from a database table. The pureQuery annotated method style is designed specifically to support both dynamic and static database access. In this tutorial, you will create a bean that represents a table. You also create an interface that declares pureQuery annotated methods that run SQL statements against this table. From this interface, implementation code is generated for each declared annotated method. You can get started quickly and easily using pureQuery tooling delivered in Optim Development Studio. When you develop Java applications with Optim Development Studio, you work with Java projects in the Java perspective. To get started, you need to create a Java project to use for this work. You then need to configure the project to add pureQuery support and associate the project with a database. If you aren't already there, switch to the Java perspective by clicking the Open Perspective button and selecting Java from the pop-up menu. Notice the Package Explorer tab in the upper left part of the Java perspective. Right-click in the Package Explorer and select New Java Project. Enter a project name in the Project Name field, and then leave the rest of the options at their default values. Click Finish. Optim Development Studio creates the Java project, and you can now see it in the Package Explorer. To add pureQuery support to the Java project, right-click the Java project folder and select pureQuery, Add pureQuery Support. In the wizard, select a database connection, or, as we do in this case, create a new connection to the GSDB database. On the Add pureQuery Support page, accept the defaults and click Finish. Your project now contains a list of referenced libraries. These libraries are the jar files for pureQuery and for the IBM Data Server driver for JDBC and SQLJ. Your project also contains a folder named pureQuery folder. This is not the folder in which pureQuery creates the code that it generates for you. Those files will be put into the source folder. After you connect to the GSDB sample database, you will work with the inventory levels table to generate pureQuery code to create annotated methods to return results from that table. Note that you can also generate pureQuery code from views, Sql statements, and more. First, let's do an optional step to change the default behavior for generation of bean field names. By default, the fields in generated beans are lowercase copies of the names of corresponding table names, as shown here. However, you can choose to use camel case for field names and eliminate underscores, so that the same column would be generated as shown here. You will see later that you can change the name of any generated field to anything you want. To select the option to camel case the names of fields in generated beans, select Window, Preferences. In the Preferences window, select Data Management, SQL Development, pureQuery. On the pureQuery page, select the option to use camel case. Now you are ready to generate code for the inventory levels table. In the Data Source Explorer, navigate to the Inventory Levels table, which is in the Go Sales schema. Right-click the Inventory Levels table and select Generate pureQuery Code. Add a name for the Java package and then click Next. You use this page to generate a test class that you can use for testing the Java bean, the interface, and its implementation. Select this checkbox to specify that pureQuery generates a test class for the interface that you named on the previous page of the wizard. By default, pureQuery names the test class by appending the word test to the name of the interface. Keep this default name. Leave the test class for inline style box unchecked, since we are not using inline style in this tutorial. Although you can use Optim Development Studio to test Java applications with JUnit, for this tutorial you will use a simple test. For connection information, leave the default selection, which means that you need to pass in the database connection URL, user ID, and password as parameters. In the other option, the connection information is picked up from your project database connection and you pass in the password as a parameter. Click Next. The Bean Fields page of the wizard specifies how pureQuery is to generate the fields of the inventory levels bean. For scope, the best practice is to use the default, which protects the fields so that they can only be modified using get and set methods. We'll also use the default names for the mapped fields, but you can change those if you like. Click Next. On the SQL Statements page, specify which statements you want pureQuery to generate as a starting set of SQL statements. Later you will learn how to edit and add SQL statements directly in the interface. By doing so, you specify how many methods and which types to include in the interface. Here we are deselecting the merge statements, which we don't need. Click Finish and let pureQuery do its thing, which is to generate 4 classes for your Java project: a bean, an interface, the interface implementation, and a test class. The bean, interface, and test class are now open for editing. Now let's look at the inventory levels bean, which is now a reusable Java object that different applications can use for accessing the inventory levels table. Go to the Inventory Levels.java tab in the middle pane. Here you can see the standard Java section. pureQuery uses the @table annotation to identify the table that the bean represents. It uses this annotation only in generated beans. When you write your own beans, you do not need to use the @table. Here you can see the fields are all declared with protected scope, as you specified earlier. Here you can see 2 constructors. The first constructor is for creating empty beans. The second constructor is for creating beans with values for all fields. Finally, you can see the get and set methods for each field. pureQuery uses an @ID annotation to identify each field that maps to a primary key column in the table. But when you write your own beans, you do not need to use that @ID annotation. Because the field names are in camel case, pureQuery uses an @column annotation on get methods to map the name of each table column to its corresponding field. The Inventory Levels Data Interface is a reusable Java object that different applications can use for querying and updating the inventory levels table. The interface declares methods, each of which is annotated with either a select, insert, update, or delete statement. Let's look at one. The getInventoryLevels method returns an iterator of the inventory levels bean. Notice that the annotation is named @select and it contains an SQL attribute. When you use a select statement, put the statement in the SQL attribute of this annotation. You can see the other methods by scrolling through the class. You can edit the SQL statements and add or remove methods. In the next module, you'll learn about features that make it easy to edit SQL in the Java editor. We hope you've enjoyed this tutorial on developing a Java application that uses pureQuery annotated methods. Try it yourself by downloading Optim Development Studio today. Other resources to help you learn are listed here as well.